Alright, so in this video we're asked to write a method called nodesAtLevels, which will basically take in a minimum parameter and a maximum parameter and return a count of how many elements exist within the spectrum of those levels there. So, for example, we have the following tree, and we call between levels 1 and 2. We return 3 because on level 1 we have 1 node, and on level 2 we have 2 nodes. The call of 7 to 9 returns 0 because 7 is beyond the height of the tree, and so is 9. For 5 and 9, we return the value of 3 because on level 5 we have 3 nodes, but beyond that we have no other nodes to add upon that. We're going to throw an illegal argument exception if a minimum value passed in is less than 1, or if it exceeds the maximum value that's passed in. We have access to the data fields, the left fields, the right fields, and the overall root to get access to the entirety of the tree. An empty tree contains 0 nodes at any level, and I believe that's all we need to get started with this. So, public return an int count nodes at levels. It's going to take in a minimum parameter, and it's going to take in a maximum parameter. And then we want to test to see if the minimum is less than 0. If the minimum is less than 1, I believe. Was it less than 1? Let me check the spec. If the minimum passed in less than 1 or greater than... yeah, okay, then, yeah. So minimum is less than 1. Or the minimum exceeds the maximum. Then what I want to do is throw new illegal argument exception. Okay, once I get beyond that point, I'm fairly good. So I want to return my private helper method here. And I'm going to take in 4 different parameters. First, I'm going to take in the overall root. That'll allow me to traverse through the tree. Then I want to look at a current level to tell what level I'm on, and I'll start off with 1. Then I want to take in the minimum and then the maximum levels. I want to take in the range here. So that'll be that. So let's move on to the private helper method here. It's going to return the type of integer. Nodes at levels, int tree node root, int current level, or I'll just call it level, and int minimum, and then int maximum. Okay, so one of the first things we want to test is we want to see as to whether or not we have an empty tree, but we also have a special case here. Because what happens if our level goes to beyond the maximum? Then what happens is we get a Stack Overflow because we keep going beyond the boundary here. So we do have to bind the level here eventually. So we're going to say if the root is equal to null or the level exceeds the maximum value, then we just want to start returning 0. The case that we could have a case where our level happens to be less than the minimum. So for example, we pass in 1 here, but what if our minimum value is like 3? Well, then at this point we just need to keep incrementing our level until we get to that minimum value. Then we'll start doing the actual counting. So the way we're going to do that is we're going to just return nodes at levels, traverse through the left side of the tree, and then we're going to increment the level by 1. Then we're going to pass in the minimum value, pass in the maximum value, and then we want to add upon that the nodes at levels, traversing down the right side of the tree, add 1 to the level, then minimum, and then maximum. Okay, so we've dealt with that. Now the last case is, okay, we're in the boundaries of our minimum and maximum here, so what do we want to do? We want to return a count of 1 plus basically all this jazz up here. And that will return the proper count for the number of nodes at between the boundaries of the minimum and maximum. And that'll be it for this video.